In this video I'm going to be talking about zeros, and then I'll be doing one application problem. So we've already learned how to solve quadratic equations, and we did that first of all by factoring. In fact, normally you want to use factoring anytime you solve a quadratic equation if it's something that you can do. That's why we need to have strong factoring skills. And then the second technique we learned was the technique of completing the square, using the square root method. That was the second one. And then the third one was completing the square, and then finally we used the quadratic formula. So in this section, as we're finding zeros, these are all quadratic equations, and we can use any of those techniques. We're actually only going to need two of them. So let's go ahead and get started here. I would remind you that if f is a function, then a 0 is any value of x for which f of x equals 0. In other words, a 0 is an input value or an x value such that when you plug it into the function, it's equal to 0. So it says find the zeros of the function, give exact answers, and approximate solutions rounded to 3 decimal places. Alright, so on number 1, let's see, we've got f of x equals x squared minus 2x minus 8. So I think this looks like something that we could factor. But first of all, let's go ahead and set the function equal to 0. And when we solve for x, that'll give us our zeros. And so I'm going to try to factor this using the AC method. We need two numbers that multiply to negative 8 and add to negative 2. Well, my factors of 8 are 1 and 8 and 2 and 4. Now, since these numbers multiply to negative 8, they must be opposites. And since the two numbers add to negative 2, we're going to make the bigger numbers negative. So that when you add, you can see 2 plus negative 4 is going to be the one that works, because 2 times negative 4 is negative 8, and 2 plus negative 4 is negative 2. So let's go ahead and plug these numbers in to factor here. And when we solve, we get negative 2 and 4. So now keep in mind, we solved a quadratic equation, but what we were finding were zeros. So these are zeros, and if you actually find f of 4 and f of negative 2, you would see that when you plug them in, you do get 0 as an output. Now I've graphed this function f off to the right here, and I want you to see there's something very important here. In fact, in your homework, you'll have to look at some graphs and find zeros and x-intercepts. It turns out there's an important relationship there. So notice our x-intercepts, that's at 4, 0, and negative 2, 0. Well, remember our zeros were negative 2 and 4. So remember, the zeros are the values that we plug in for x, and the output or the y value is 0. And on the graph, that means that the height of the graph is 0. And that occurs, basically our zeros occur at our x-intercepts. So I'm going to make a note here. If x equals negative 2 is a 0 of f, then negative 2, 0 is an x-intercept on the graph of f. And similarly, if x equals 4 is a 0, as it is here, that also tells us that the point 4, 0 is an x-intercept on the graph of f. Alright, so let's move on to number 2. Now, let's go ahead and set this equal to 0. Two numbers that multiply to negative 7 that add up to negative 3, we're not going to be able to factor this one. So I would go ahead and use the quadratic formula. It doesn't look like completing the square would be a good idea. Minus 3x, it's not an even number, the negative 3 there. So I'm just going to go ahead and use quadratic formula. So I'm going to write it out. And we need to identify a, b, and c. So a is 1, b is negative 3, and c is negative 7. I'm going to go ahead and make a shell of the quadratic formula. Wherever there was a variable, now there's parentheses, and I'm going to plug in a, which is, I'm sorry, b, which is negative 3, a is 1, and c is negative 7. So now we need to simplify this. A negative negative 3, we're going to get x equals 3 plus or minus square root. Let's see, we have 9. We've got to square first. 9 minus 4 times 1 is 4 times negative 7. It's going to be minus negative 28 here, which becomes 9 plus 28, which is going to give us 37. And in the denominator we have 2. So you can write your answer this way, or you can break it into two fractions and it looks like that. All right, let's move on to number 3. So again, we're going to set this equal to 0, and I'll let you know it actually doesn't factor. You could try and you'd see that it doesn't work. So again, I'm going to go ahead and use quadratic formula. So there's my a, b, and c. A is 2, b is 3, and c is 2. And I'll write down the quadratic formula. And I'm going to go ahead and make a shell. And let's plug in a, b, and c. All right, so let's see. We're going to have negative 3 plus or minus. We've got 9 minus 16 under the radical. That's going to be negative 7. 2 times 2, of course, is 4. Now keep in mind, square root of a negative we know is going to be imaginary, so we can pull out an I there. And so we end up with this final answer here. All right, let's move on to an application problem. It says the formula s equals 16t squared is used to approximate the distance s in feet. So that's distance s that an object falls freely from rest in t seconds. So our equation has two variables. It's important to know what each stands for. Now they're probably going to give us one of the variables and we got to find the other one. It says how long would it take an object. So notice how long, that's what we're looking for, and that would be time. Oops, let me write that a little bit better. How long would it take an object dropped from the top of a 630-foot building? So notice they're giving us s there, or the distance. And so now I'm going to go ahead and write the formula. And we're going to plug in s, and we need to solve for t. So let's divide by 16 on both sides. And then we need to take the square root of both sides. Now keep in mind, this is time, so we're going to disregard the negative. It's just going to be 6.27, or it's about 6.3 seconds. All right, and that'll be it for this video.